Hey everyone, welcome to week two. Hopefully, you survived week one. Um, Week two is going to get a lot more work intensive. Uh, Week one is kind of setting the foundation for what we want to do moving forward with calculus. And I tried to give you guys kind of an easy week so you can get used to, this online class and the differences. Um, so, just to give you fair warning, there's going to be a little more work. The homework is a little longer than the one I gave you before. I tried to keep it as short as possible while still giving you enough practice. So hopefully I found the right balance there. Um, as always, if you need help, you can reach out to me. There's all the things I put online. There's Khan Academy, there's YouTube, there's the book, there's Paul's online math notes. There's a whole bunch of stuff. So if you run into any problems, don't hesitate to use any of those or to contact me. I'd be glad to help. So let's talk about derivatives. That's pretty much going to be the focus this week. And just to give you a big picture idea of what's going on, calculus kind of splits into two areas once you deal with limits. And both of these things are based on limits, but you can kind of take it two different directions. The one we will cover a couple weeks from now is called integration, right? And that we'll worry about later. For now, the other half is something called derivatives or derivation. And essentially, what I want to do, right, is I want to look at a curve. And I want to look at what's called the tangent line to a point on that curve. So if I have a curve here, and I have a point A, and I go up to the curve, when I draw the tangent line, what I'm going to do is I'm going to draw a line that just touches the curve at that point. So something like this. This red line would be our tangent line. And what I'm interested in is what the slope of that line is. Because if I have something like a line, right, lines have slopes. This is nothing new, right? You've been finding slopes of lines for forever. We have the mx plus b slope-intercept formula that you've done in algebra. So that's not anything different. But if we don't have a line, if we have something like a curve, right, the slope is going to be different here than it is over here. Okay, so what I'm going to do is I'm going to draw this tangent line. I'm going to look at what the slope at that point looks like. Okay, so there's a couple ways you can do this. And the way that we are going to focus on, right, is using something called the secant line. So we have a tangent line and we have a secant line. So the secant line involves me picking another point. So we'll take this blue point here that is a little farther away from where we're at. And then I'm just going to draw the line between the point I'm interested in and that new point. It gives me something like this. Okay, so if you'll excuse my crappy drawings, you can see the blue line is kind of similar to the red line, right? Especially when we talk about slope, but they're a little bit off. And so there are ways we can make that better. So instead of picking a point really far away from the point A that I'm interested in, what I'm going to do is I'm going to scoot that point closer to the one I'm interested in. And so for this one, we'll do this in green. If I pick a new point in green and I draw a new line between the point that I'm interested in and the new one, you can kind of see it squeaks right in the middle between the blue one and the red one. I have the green one, so it's closer to the red one, it's closer to what I want, but it's still not quite there. So this is where the idea of limits comes in, where I say, okay, well, if I move the point closer, I get a better approximation of what this red line is. So let's just scoot it as close as possible. So why don't we take the limit as this point gets closer and closer to the point I'm interested in. Now the reason we do this rather than just looking at the red line is because with the red line we only have one point on that line. With the blue line and the green line, I have 2 points. And if you have 2 points on a line, you can find the slope. You do y2 minus y1 over x2 minus x1. So that rise over run formula that you remember from forever ago. So that's what we can do, right? If I take the limit of this secant line as it gets closer and closer to this point, then that's going to eventually give me the tangent line. And so that's how our limit is based on all of this. So with our limit and with this knowledge and the slope of the secant line, and basically it's just our slope formula. So those two things combined give you Voltron, which is in math terms the derivative. So once we find that derivative of that tangent line, there's a couple different things we can do. So first off, we can find the equation of that line because we have the slope of the line and a point on the line. So we can find the equation of the tangent line to the curve at that point, right? So that's how it's phrased. Tangent line to the curve at the point, whatever, right? Wherever we found our derivative. We can also just find a derivative more in general. Rather than picking a point, if I just find the derivative with a placeholder, so rather than plugging in 3, I just plug in x, right, our general placeholder, then we get a function. And that function will actually tell us the slope of the tangent line wherever we decide to plug it in. So if I want the slope of the tangent line at 3, I just plug in 3. But if I want the slope of the tangent line at 5, I just plug in 5. And so I have this formula, this nice little formula that I can use to find the derivative, right, the slope of the tangent line at any point on a curve. And so section 2.7 is going to deal with this idea right here. Section 2.8 is going to deal with finding that general formula for the derivative. Now the actual version of that formula, right, you can look it up. It's called the definition of a derivative. So the limit as h approaches 0 of f of x plus h minus f of x all over h. Right, so that thing is very important. It's called the definition of a derivative, and that is essentially the slope formula, right, but just reworded slightly differently. So if you're interested, right, you can talk to me, or you can look on Paul's online math notes or in the book. All those places have it, and you can see how we go from the slope formula, the y2 minus y1 x2 minus x1 thing, to that new formula. But that's essentially all that it is. And we can use that to, again, find either the actual slope at a point or a function that gives us the slope at whatever point we want to plug in. The problem is evaluating that limit sucks. So rather than doing that limit every single time we want to take a derivative, people have done it kind of generally. So rather than plugging in something like 3x squared, right, they plug in like, you know, cx to the n, right? They take out all the numbers and they put in variables and then just work it out and see what happens. And when you do that, what ends up happening is you get different rules. Think of them kind of like shortcuts for a derivative. They're all based on that limit formula, but we can kind of skip over the middleman and not worry about the limit. And so these are the rules you're going to learn in chapter 3. So we're doing 3.1, 3.2, 3.3, and 3.4 this week, in addition to the other two. So 2.7, 2.8, those are all our definition of a derivative kind of things, right? That's the stuff we talked about. The rules aspect of it, kind of the shortcuts, if you want to think of it that way, right? 3.1 is going to teach you how to deal with polynomials and exponential functions, so things like x cubed or e to the x, things like that. And then we're going to figure out how to take derivatives of those in a nice, easy fashion. We have something called the power rule, which is going to help a lot there. Once we do that, we'll talk about the product rule and the quotient rule. So essentially what happens if you have two functions multiplied together? So like, rather than an x cubed, right, you take that derivative, and e to the x, and you take that derivative. What if we have x cubed times e to the x, and we want to take the derivative of that function, right, that multiplication? Or what if we have x cubed over e to the x? So we have a quotient now where we have a function on top and a function on bottom. And so the product rule and the quotient rule will help you figure that out. Then we'll talk about derivatives of trig functions. So trig functions being sine, cosine, tangent, and then secant, cosecant, cotangent. So all our reciprocal functions too. So we'll have 6 different formulas for each of those. So for example, the derivative of sine is cosine, derivative of cosine is negative sine, and there will be 4 other rules that you'll want to write down and make sure you know. Once we do that, we move on to something called the chain rule, which is basically what happens when we take a composition of functions. So if you remember, a composition of functions is essentially when we have one function inside of another. So rather than e to the x, right, we would have something like e to the x cubed, right? So I have that x cubed function and then the e to the x part. So e to the x cubed. So I have e raised to another function. So I have a function inside another function. If you wanted to think of it as functionception, then that is both one of my favorite puns and a good way to think about it. So the chain rule will help you deal with situations like that, where we have a composition of functions. And one of the things I would recommend when you get to that section is try and identify what your outside function is and what your inside function is. So this will make 0 sense right now if you're looking at this before you've done the work, but once you have come back to this point, we are at 11 minutes and 30 seconds into the video, so there's your timestamp for you. Come back to this point. When you are at the chain rule, identify what your inside function is and what your outside function is. So for example, in e raised to the x cubed, your inside function would be x cubed, that's the thing inside, and then e raised to the something, right, is your outside function. So you have e raised to the blah, and then you have x cubed. And those are your 2 functions, and you want to figure out which piece is inside and which is outside, because that's going to help you a lot when it comes to the formula. So take a look at that once you get to that point. But otherwise, the thing I would recommend the most going through this is write down all of the rules. So product rule, quotient rule, power rule, exponentials, all this stuff, chain rule, all of it, definition, derivative, all of it, on a separate sheet of paper. Okay, write it down in whatever notebook you're keeping all these notes in when you read through this thing, but write it down on a separate sheet of paper, because what's going to happen is when you go through the homework, you're going to want to reference those rules fairly often, and so flipping through your notes gets kind of tedious, and so it's much nicer to have kind of a separate sheet of paper that has all of those notes built in and all those special rules. And what you'll find is as you go through the homework, you'll start looking at it less and less and less, and that's the goal. By the end of the homework, you should be not looking at it at all, so that when you take the quiz and when you take the test, which I'll talk about in a second, then you won't have to reference it, which is good because you can't reference it. So make sure that's kind of what you're doing, right? As you go through the homework again, you're trying to train yourself so that when it comes to the quiz and the test, right, you can do everything with just your brain and a scientific calculator. So keep that in mind as you go through. Keep this kind of like, side sheet of paper with all of your notes on it, and that will help a lot. Now, when it comes to the test, just a quick thing on that, it's going to be very similar to how the quiz is set up, with the exception of the fact that you don't get more than one try. So with a test, you get one shot at it. It will be a little bit longer than the quizzes, and it will encompass everything we've done in these first 2 weeks. So everything from limits to all of the derivative rules that we will cover this week. The next test we'll worry about later on. Ways to prep for that, I would strongly suggest looking at the quizzes, right? Looking at those problems and seeing what stood out to you as difficult, right? And then going back into the homework and trying to review the problems that best represent the problems in the quizzes that you found difficult, right? If you work on the stuff you found difficult and you get that up to speed, then that plus the stuff you were comfortable with is going to mean you're going to be very successful on the tests. So the other thing I'd recommend on the tests is, of course, we're having to do them on a computer, which is advantageous because you get instantaneous feedback. You will immediately know what you get on the test. It is unfortunate because it does make partial credit difficult for me to give. Whereas in a written test, I can kind of see what your thoughts were and things like that. And in an online test, I can't do that. So, what I would recommend is as you're prepping for the exam, try your best to teach yourself how to go back through problems. Meaning, when you do a problem and you get a final answer, this isn't going to be like the homework where you click submit and then it tells you it's wrong and you're like, oh man, I missed a negative here. You're not going to have that. So train yourself to go back through and look at the problem, go back through it, check your work, make sure all your signs are correct, make sure you plugged your numbers correctly into a calculator, all that kind of stuff. Because that is going to save you a lot of headaches down the road where you get on the test, you do everything right, but you missed a negative or you like accidentally plugged in 3 instead of 4 into the calculator. And the computer doesn't care. The computer's just going to murder that and be like, nope, that's not right. Not feeling it. Even though you basically had it right, you just made a simple mistake. So focus on those simple mistakes. Try and get rid of those before you take the test. Try and teach yourself how to recognize those simple mistakes. And that will help a lot when it comes to test time. If you have any other questions on the test or if you have any questions on the material, please feel free to talk to me. Other than that, I'm going to stop yapping at you and let you try and tackle the monolith that is this week's homework. Good luck.